Hello and welcome to the Unit 5 Section 4 video on solving rational equations. So in Section 2 we talked about simplifying rational expressions, and we're going to use some of that to solve rational equations because we'll be working with rational expressions when we work with rational equations. So really the one thing that we have to hit here at the beginning of this section is finding the least common denominator. And you did that when you added and subtracted rational expressions that did not have a common denominator. So this is really nothing new. We're just throwing an equal sign into it. Okay? Now it is easier to solve rational equations if the fractions are eliminated, and that is what we're going to do first, is we are going to eliminate the fractions so that we can have something easier to work with. The most efficient way to do it is by finding the least common denominator and multiplying each side by that. But really, don't get too hung up on finding the least common denominator. As long as you find a common denominator of some kind, then it's going to work for you, okay? You don't necessarily have to find the least common denominator, but we'll kind of aim to try to find the least common denominator here so you see what that looks like. So let's do some examples of this. Let's solve this first example, okay? So when we do that, we are going to find our least common denominator. Well, there's only one denominator here, and that is x. So we are going to multiply each side by x. Because remember, whatever you do to one side, you have to do to the other. Now, we just multiply out. X times x gives you x squared. X times 8 over x, the x's cancel, so you get 8. And then you get 6x over here. Let's move our 6x over to one side. If you have a square, then you want to move everything over to one side so that you can try to solve the quadratic equation that you're given. Okay? So let's see, first of all, if we can factor it. And the good news is, yes, we can factor it. This factors into x minus 2 times x minus 4. So since that did factor, we set each equal to 0. And when we do that, we get x equals 2 and x equals 4. So our solutions are x equals 2 and x equals 4. Let's move down to the second example here. Now we have several different denominators going on. Well, we know, first of all, that we're going to multiply each side by something. So let me just write what we have on each side and get it ready to be multiplied. All right. So let's start with the one with the variable. We've got x plus 2. So we do know we have to multiply each side by x plus 2. Now let's see what else we have. We have 28 and 4. Well, 4 does go into 28. It goes in 7 times. So we don't need to multiply by 4 and 28. We only need to multiply by 28 because 4 is already covered in the 28. So we'll multiply this side by 28. And we'll multiply this side by 28. So now let's multiply out. Well, if we multiply this first set here, the 28's cancel, and we're left with 9 times x plus 2. If we multiply 3 over x plus 2 times these two terms on the outside, the x plus 2's cancel, and you're left with 3 times 28. And then on the other side, you have 3. 28 divided by 4 gives you 7, and then you have x plus 2. Now the fractions have been eliminated. Let's just distribute all of this information. So we've got 9x plus 18. 3 times 28 gives you 84. And that's going to equal 3 times 7 is 21. 21 times x is 21x. 21 times 2 gives you 42. Now, let's combine our like terms. Okay, let's get everything that's got an x on one side and everything that doesn't have an x on the other. So 18 plus 84 gives us 102. 102 minus 42 gives us 60. 21x minus 9x gives us 12x. Divide each side by 12. X equals 5. So really the name of the game here is, very first step, let's eliminate our fractions by finding that common denominator. All right, let's move on down. There is one other topic that has to be covered for this section, and that is extraneous solutions. Because remember, when we have things on our denominators, then whatever x value makes that denominator 0 cannot be a solution. We either have an asymptote or we have a hole. And those values for x that create an asymptote or hole are going to be our extraneous values, or our extraneous solutions, which means we're going to throw them out of our final answer. Okay? So you always want to check to see if those values should be eliminated, the ones that you get for x, if they should be eliminated by substituting them back into the original equation. So let's do an example of that. So in this one, we are going to find our common denominator, which isn't difficult because the denominator on each side is m minus 3. So to get m minus 3 to be eliminated, all we have to do is multiply each side by m minus 3. Now this may be a little bit of a shortcut for you, but if you have the same denominator for everything, you can eliminate the denominators and just go with the numerators, because when we multiply each side by that common denominator, what we're left with is just our numerators. And then here we get m equals 3. Well, let's do a check. Let's plug in 3 for m on the top and the bottom, wherever there's an x, or in this case an m. And you very quickly see that we end up with 7 over 0 equals 7 over 0. Well, you can't divide by 0, okay? So since you can't divide by 0, then m cannot be 3. So therefore, since that was our only solution for m and we had to throw it out, there are no solutions in this problem. And that would be your answer. Now, you don't have to do this check out by hand. I think it's fairly easy to see. If you put 3 in here, you can see the bottom's going to be 0. You can see the bottom's going to be 0 the other one. So you don't have to physically write down this check necessarily unless you have something a little bit more complicated. It does well enough just to check your values, just kind of put them in and mentally determine, are you going to end up with 0 on the bottom? Let's look at example 4. So this one, we're going to have a little bit more work to get rid of the fractions here, but it's not terrible. So we have x minus 7 and we have a 2. So we're going to multiply each side by 2 times x minus 7, because that will eliminate our fractions. And when we do this, we end up with the x minus 7's canceling on this one, so we end up with 2 times 2x minus 9. The 2's cancel here, so we get plus x times x minus 7. And then on the right-hand side, we are going to end up with 5 times 2. So let's distribute. You get 4x minus 18 plus x squared minus 7x equals 10. Now you notice we got a square term, so we want to get everything on one side. So let's lead with the x squared. We have a 4x minus a 7x, so that gives us negative 3x. And then negative 18, subtract the 10 from it, you get negative 28. And then we see if we can factor it. And as it turns out, we can. We get x minus 7 times x plus 4. So our values for x are going to be -7, or I should say +7 and -4. Now let's check our values. If we put 7 into our original equation, we do end up with 0 on the bottom. So we have to get rid of the 7. If we put -4 in the bottom, that's okay. -4 minus 7 gives us -11. You can divide by -11, so our final answer is x equals -4. That's our one and only solution that works. All right, let's finish off this section and this unit with a word problem. So, Jason can clean a large tank at an aquarium in about 6 hours. When Jason and Lacey work together, they can clean the tank in about 3.5 hours. How long would it take Lacey to clean the tank if she works by herself? So, we have Jason's rate. We're going to first of all talk about this in terms of at what rate can Jason clean the tank and at what rate can Lacey clean the tank. Okay, so Jason's rate, well, if he can clean the entire tank, one full tank in 6 hours, how much can he clean in 1 hour? Well, he can clean one-sixth of the tank. Okay, so he can clean 1/6 of the tank per hour. That is his rate at which he cleans. Well, Lacey, we don't know what Lacey's rate is. So we're going to put a variable in place of it so we can solve it. Well, if it takes Jason 6 hours to clean the aquarium and he can clean 1/6 per hour, if it takes Lacey H hours to clean the tank, then she can clean the tank at 1/h of the tank per hour. So now we're going to do an equation that we set up here. So we're going to talk about the work that they do together. So Jason's rate times the hours worked plus Lacey's rate times the hours worked is going to equal one complete job. Okay, so Jason's rate is 1/6 of the tank per hour. And he can clean, he spent 3.5 hours working, because this is the job that they did together. Okay, so he spent 3.5 hours working at a rate of 1/6 of the tank per hour. Then we're going to add that to Lacey's rate, which is 1/h. She also spent 3.5 hours working, and that gave us one complete job. What is our common denominator here? We have a 6 and an h, so our common denominator is 6h. So 6h times 3.5 over 6 plus 3.5 over h equals 1. So 6 is a common denominator here. So we've got 3.5h. The 6 is canceled in the first one. The h is canceled in the second one, so we have 6 times 3.5 equals 1. And remember, we have to multiply that 6h on each side, so we actually have 6h on this side. All right. 6 times 3.5 is 21. We subtract 3.5h from each side. You get 21 equals 2.5h. And you do 21 divided by 2.5, and you get approximately 8.4. Now remember, word problems call for kind of word solutions. So we got to put this into context. So we will do that here. It will take Lacey about 8.4 hours to clean the tank by herself. And that would be your final answer. And that does it for not only this section of notes, but it also wraps us up for Unit 5.